Hello all, welcome to the channel. Today we will be solving question number 10 of next 2025 exam. The question says, consider the following circuit with capacitor C1 and C2 having equal capacitance of 2 microfarad. Two switches S1 and S2 are closed at T is equal to 0. So at T is equal to 0, both these switches are closed. After a long time, what are the charges stored in this capacitor? So first of all, it has been said that at T is equal to 0, the switch are closed. So as soon as the switch is closed, the charges will start flowing and eventually they will get stored in these capacitors. So for that, we know that at T is equal to 0, the resistance or the reactance due to capacitor gets seen and written as 1 upon omega C. Now omega is written as pi by T into C. Now this 2 pi by T I can replace it as T by 2 pi into C. So basically, XC directly depends on T. That means that T is equal to 0, resistance will be equal to 0, and at T is equal to P infinite, resistance will be infinite. That means at T is equal to 0, we can consider these capacitance as wire. At T is equal to infinity, we can consider these capacitance as open circuit. So now, if I consider at t is equal to 0, I have to find the charges stored. So for t is equal to t is equal to infinite for after a long time passed, this will behave as an open circuit. Now, if I and this will also become an open circuit. So now, if I redraw the diagram, I will get the diagram like this. Just the 2 micro ohm here, kilo ohm, and the 4 kilo ohm here, and there is a ground between. This is the total circuit. This is 6 volt, this is 2 kilo ohm, and this is also 4 kilo ohm. Basically, this is a circuit diagram. So from here, if I try to find the current in the circuit, that is, first of all, R equivalent, since these both are in series, so R equivalent is equal to 6 kilo ohm. P is equal to 6 volt. So I will be equal to, or the current through this will be equal to 6 by 6 kilo ohm, that is of the milliampere. This is the current that will be flowing through this circuit. Now, what will be the potential difference across this resistor? Why we are finding this? Because if we get the potential difference across these resistors, then we can eventually get the potential difference across the capacitor. So if I get the potential difference across the capacitor, I can use the value of capacitance and then find out the charge stored. Therefore, due to this, I am trying to find out the potential difference between this. So for that, now with what amount of charge must have flown through 4 kilo ohm? Since it is in series, all charge will flow through this 4 kilo ohm resistance. Therefore, potential difference across the 4 kilo ohm resistance V is equal to I into R. I is the same, that is 1 milliampere, and for R it is 4 kilo ohm. So basically, potential difference across this is equal to 4 volts. Now we got the potential difference. That means we got that across this there is a potential difference of 4 volts. As this is grounded, so this will be 0 and this will be 4 volts. So we calculate this part. Now, for infinite time, at time is equal to infinity, will act as a open circuit, and therefore no current will flow from this kilo ohm resistor. That then the 4 volt will solely provide the potential difference to capacitance. Therefore, we can write the potential difference of the capacitor C1 is equal to 4. Now, the capacitance is given as 2 microfarad. So, charge stored is equal to C into V. That is 4 into 2 microfarad. That is 4 volt into 2 microfarad. Here it is from it's 4 volt into 2 microfarad. That is 8 microfarad. So basically, uh, the charge stored in C1 is 8 microfarad. That means the energy gets stored. Now we have to check whether what is the charge stored in C2. Similarly, now considering this circuit, the right circuit. Here, if I just consider this as open circuit, there will be no current flowing through this 2 kilo resistor as well. And there is a potential difference of 4 volt. Basically, I can consider it as like this. One side is 4 volt connected to capacitor, and another side is this part is minus 4. This is the configuration for the capacitor circuit. And eventually this is 4 volt that is connected to the ground. So this is the complete decode part of C2 capacitor. Now, based on that, I can calculate the potential difference across C2. That is, C2 is equal to 4 minus of minus 4. That is 8 volt. Now, I got the potential difference. I have to calculate the Q. Q is equal to C into V. Capacitance across this is 2 microfarad into potential difference that is 8 volt. So, the charge stored in C2 C is equal to 8 into 2, that is 16 microcoulomb. So therefore, in C1 8 microcoulomb is stored and in C2 16 microcoulomb is stored. Option A is the correct answer. Hope you understood the solution. Thank you for watching.